Hello all, my name is Patricia Barnett, and in this presentation I will be conducting a correlational analysis and taking you through the process. So first on the agenda, we're going to give an overview of the process. We're going to examine the dataset variables. I'm going to present the findings in which we found significant correlations. We will finally go over our main takeaways. I will present the references I used for this presentation. And finally, we will close the presentation with any questions. So an overview of the process. First step is to open PSPP and import the data, which I did. And step 2 is state the hypothesis, which would be the null. There is no correlation between the first continuous variable and the second continuous variable, or r equals 0. And the alternative hypothesis would state that there is a correlation between the first continuous variable and the second continuous variable, or r is not equal to 0. R is the APA symbol for the correlational statistic, which is one of the outcomes that we will see in PSPP. And the rejection rule, we can reject the null when the p-value is less than alpha, where alpha is equal to 0.05, which is another outcome we will see out of the PSPP results. And finally, step 3, we'll interpret the results. R will always be between negative 1.0 to positive 1.0. And we'll go over the significance of those values in later slides. And a direct or positive relationship will have an upward sloping best fit line where r is greater than 0. An indirect or negative relationship will have a downward sloping best fit line where r is less than 0. And if there's no correlation, there's no best fit line and r is equal to 0. However, in this presentation, we're only going to go over the results where there were significant relationships. So the dataset variables, what variables will we be researching in PSPP for this presentation? So on the right, we have 10 sets of combinations of outcomes. We are conducting the analyses between these 10 combinations of variables, and per the instructions on the assignment, we should find 6 significant correlations, which is what I have highlighted or bolded between income and savings, income and stocks, income and wallet, savings and stocks, savings and wallet, and stocks and wallet, and we will go into more detail on subsequent slides. So the first significant result we found, we stated that the hypothesis, the following correlational test was conducted between income and savings. So the null hypothesis stated there is no correlation between income and savings. The alternative stated that there is a correlation between income and savings. And once we did our analysis in PSPP, in which we ran that by selecting the bivariate correlations, two-tailed test, and to flag significant correlations, we found the following. The correlation coefficient and its p-value were calculated using PSPP, as I mentioned, assuming that alpha equals 0.05. A significant correlation emerged where r, or the correlation value, equaled 0.91 and p equaled 0.000. The test rejected the null hypothesis and concluded there was a correlation between income and savings. And the reason that we rejected the null hypothesis is that the p-value is less than alpha. So what that looks like in PSPP as an output is this. So income and savings were, the relationship was calculated, and right there the 0.91 is where we get the r value, the 0.000 is the p-value. On this next slide we'll see that graphically on a scatter plot. So again, continued income versus savings, we can see that there is a pretty direct relationship because the best fit line is sloping upward, fairly strong relationship. So the R value of 0.91 indicates a direct relationship since R is greater than 0, and we see that's a fairly strong relationship the closer that the R value gets to positive 1. And of course we see it as an upward sloping best fit line. The next significant result we found was in the correlation between income and stocks. So again, just like the previous example, the null hypothesis is there is no correlation between income and stocks. The alternative is the exact opposite, that there is a correlation between income and stocks. And again, the correlation coefficient and its p-value were calculated using PSPP. Same assumption, and we see that the significant correlation emerged, or R equals 0.19 and the P equals 0.018. So the test rejects the null hypothesis and concludes that there is a correlation between income and stocks. Again, graphically, we see that on a scatter plot. It's not as a strong relationship as the previous example because the R value is only equal to 0.19, but still that is a positive relationship with an upward sloping best fit line, as we see there. The third significant result we found was between income and wallet. Again, the same null hypothesis that there is no correlation between income and wallet. The alternate is the opposite, that we would see a correlation between income and wallet. I ran the bivariate correlation analysis and found that, again, a significant correlation emerged. In this case, R equals 1, so that's as high as you can get in a correlation test, and P equals 0.000, which we can say that this is a very accurate result we can expect. And the test concludes that there is a very strong correlation between income and wallet. So we can see the output is 1.0 for the p-value again, and 0.000. And graphically, you can't get any more direct than this best fit line. It is exactly 1. So it indicates a direct relationship since R equals 0, R is greater than 0. It actually equals 1. So that's as direct as any relationship can get between two variables. So we see income and wallet has a direct relationship, and it is an upward sloping best fit line. The fourth significant relationship that we found was between savings and stocks. Just like the previous examples, the null hypothesis would be that there is no correlation between savings and stocks. And the alternative, of course, is there is a correlation between savings and stocks. So once we run this in PSPP, again, a bivariate correlation analysis, we see that with the same assumptions, a significant correlation emerged. R equals 0.28 and P equals 0.00. So that's the relationship between savings and stocks. And seen in our output is that in PSPP. And graphically, as seen on a scatter plot between savings and stocks, again, R equals 0.28, and it indicates a direct relationship since R is greater than 0. This is a bit of a less upward sloping line as we saw in the previous example where it was as direct as you can possibly get. So this line slopes just a bit less, but it is still upward sloping. And next we have the fifth significant result, our hypothesis test, and this tested the relationship between savings and wallet. So again, our null hypothesis would state that there is no correlation between savings and wallet. The opposite, our alternative hypothesis, would state that there is a correlation between savings and wallet. So once we run our test in PSPP, the same assumptions again, that alpha equals 0.05, a significant correlation emerged in which R equals 0.91. So that again, that's indicating a very strong direct relationship, and the p-value equals 0.000. So again, a very fairly accurate result. Again, the test rejected the null hypothesis and concludes there is a correlation between savings and wallet, which we see as our output. Again, 0.91 for the R value and 0.000 for the p-value. And seen graphically, this is Again, a very strong direct relationship. We can see all of the points there on the scatter plot are clustered very closely, which makes sense that our R equals 0.91 and indicates again a direct relationship since the R value is greater than 0. And of course we see this again as an upward sloping best fit line. Our final significant result was between stocks and wallet. So our null hypothesis would state there is no correlation between stocks and wallet. The alternative, again of course, would state there is a correlation between stocks and wallet. And the output from PSPP gives us this result. The R value equals 0.19 and the P value equals 0.017. So again, we can reject the null hypothesis since the alpha is less than 0.05, and we can conclude that there is a slight correlation between stocks and wallet, but there is still a correlation there, and that's our output in PSPP. And once again, graphically, this is the scatter plot of stocks versus wallet. They're a bit more scattered, but we can see that the best fit line does indicate an upward sloping line. So R equals 0.19, which is slightly sloping upward, and we can see the best fit line there. So our main takeaways from this exercise. In a correlational test, an R value of 0 means that we can accept the null hypothesis, which states that there is no correlation between two continuous variables. Those examples of which we did not go over in this because we would just see a random scattering of dots if we saw it graphically. In a correlational test, an R value not equal to 0 means we can reject the null hypothesis, or there is a correlation between two continuous variables, which is what we did go over in this presentation. And as an aside to that, we can reject the null per the rejection rule, which states we can reject the null when the P value is less than alpha, where alpha equals 0.05. An R value greater than 0 indicates a direct or positive relationship, which happen to be all of the significant correlations we found in this exercise. An R value less than 0 indicates an indirect or negative relationship, which would be a downward sloping line seen graphically in the scatter plot. And an R value equal to 0 indicates no relationship. Here are the references I used, which were the two videos that we viewed for our lectures. And finally, if you have any questions, please let me know in the comments, and thank you again for watching.